So we do have shortcuts that we can use to solve these problems, but remember, all of these problems are based upon fractions or proportions. Okay? And so the first problem, if 65 is out of 80, what would the number be out of 100? That's what we mean when we say solve a percentage problem. Okay, a basic percentage problem is really a proportion, and we're just scaling the proportion to be per 100. Okay, so one way you can solve the problem is by solving this problem. Another way you can solve this, what people do, is they divide, and so 65 divided by 80, right, that would be 0.8125. Now, when you do that, you're changing it to be per 1. That's what you're doing when you divide a number by a number, making it now per 1. And so this is really a problem we're solving. And notice when you cross multiply, you multiply 100. Okay? Let's write this down. Sorry, y'all. So let's see anything and who else? Okay, so when you divide, you're actually changing it to be per 1, right? And now this is the actual problem you're multiplying. Notice you're multiplying 100. That's why people move the decimal point to places. That's why people divide and move the decimal point to places. All right? And what that percent symbol means, the reason we put it behind the number is because this really means that's the number per 100. Okay, now that's where all this stuff is related. But after solving an infinite number of percentage problems, we just start taking shortcuts. Okay? So, all right, on the second problem, this next two problems are similar. Okay, you can do the is of procedure sometimes. Okay, so 10 is 5% of what number? All right, well, 10 equals 5%, 0.05 of what number? Okay, is means equals, means times. That's just a shortcut. Okay, and then it's hard to rely on shortcuts all the time because sometimes we use these words differently. But this is what you could do. Another way to set up this problem. All right, what would 10 be out of if the basic ratio is 5 out of 100? All right, it's just another way to set it up. But you can use the sentence to write an equation. Just remember that when you get your percentage, you need to change it to a decimal, because that decimal came from this fraction. That's why I change it. And again, after a while, you just do that instinctively. You don't think about it. Okay, and then we've got the next problem. The next problem, again, is of basic percentage. So now what number is 15%? 250. Okay, so what number? We don't know what it is, the variable. Is means equals. And then it said 15% of 350. Okay, so this is how we could set that up. Okay, and then notice when you multiply a number between 0 and 1, that's going to give you a portion of that larger number. How much out of the 250 is 15%? How much out of the 250 equals 15%? So if it's 15 out of 100, what would it be out of 250? That's really what that problem's asking. Okay? All right, so now we got the next two problems, and the next two problems, including the sixth one, those are percentage of increases and decreases. Okay, when we do number 4, you get a 12% discount. So that means we're going to get a 12% decrease off of the normal price of 120. Okay, so 120, and then we take away 12% of 120. Okay, so this is how you could set that up. And remember, this comes from a percentage. Now, you might remember earlier this semester where we started to use growth factors. All right, so 1 minus is the growth factor. If it was an increase, we do a plus. And then we multiply that to the 120. It's just another shortcut. Another way to think about it. When we do the subtraction, we're going to get 0.88. All right, and that means we got 88% left. So we only have to pay 88% of the $120. That's another way to think about it. You know, these are all related. It depends upon where you're at. You may prefer this method. Okay, then we got the fifth problem, which is similar. The fifth problem is similar, but the fifth problem is based upon an increase. Okay, so tax. We got to pay tax on the $15,000 car. All right, so we're going to add the tax to the $15,000. Okay, so the quick way again. Now notice I moved the decimal point 2 places. Be careful, but sometimes we just put the decimal in front of the number, right? 8%. Notice the 8 is the second digit after the 0. 8.75%. So again, sometimes we goof that up. All right, and we're adding because this is increase, and this would be the tax. Okay, now again, you might remember the growth factor. So we could go 1 plus for number 5 to get our growth factor. And then multiply that with 15,000. Okay, and again, that's just a shortcut. You might remember that when we had this in the first part of the semester. Okay, now the last problem. Now the last problem, we want to find the percentage of increase. So over the course of a year, our revenue went up by $50,000. So we made a little more money the next year. Okay, so this is where you want to subtract and always divide by the original. The percentage is always based upon where you start, not where you end up. And we sometimes goof that up because the last number we see, we put on the bottom of the fraction. All right, so just be careful with that. And then this equals what percent, which means a number over 100. So this is how you would do that. Now, when you subtract, the reason you get 50,000 because that was the increase. That's how much more money you made the next year. And originally you were making 400,000. Next year you made 50,000 more. So that's what that really means. And you know, it's always a good idea to simplify. So you could go ahead and simplify this fraction down to 5 over 40, and then solve it from there. And then just like the first problem, you could divide and move the decimal point.